be the one that travels the farthest, right? The solvent, which is isopropyl alcohol, is somewhat polar. It's not very polar. It's not water, but it has that OH group, right? Any alcohol does. So we consider that slightly polar. The blue dye is less attracted to it and more attracted to the paper. Why? Because, well, the blue dye, it tells you here somewhere, the blue dye is less polar, therefore it's attracted to the paper itself, right? And so the solvent can't move it up as fast as the one that is going to be attracted to the solvent. Make sense? Okay. It's usually slightly polar, which is really considered. All right, so chromatography takes advantage of the differences of the intermolecular forces. You have mobile phase and stationary phase, knowing which one is which, and it'll tell you the solvent will change, right? In one example, the solvent was hexane, which is very nonpolar, and in the other one, it was alcohol, which is slightly polar. So depending on the solvent, it's going to move up at a different rate. Yes? Mobile is a solvent. It's the one that's moving. Stationary phase is the paper. Right? That's the one that's going to stay stationary. There are no molecules moving. The paper is not a molecule that's moving. Everything else is moving. Yes? We usually measure a distance called the RF value, which you guys should have done in AP Bio. As part of the curriculum, RF value. The distance of the paper. We don't really do that much in chem, but Bio does it. Nope. Office hours. I don't. Okay, so the other separation, what I was talking about with the sand and the salt and so on, is distillation. Like I talked about that round bottom flask, if you remember. And that also separates based on intermolecular attraction, but based on boiling points. And of course, boiling point has to do with the intermolecular forces as well. Okay, so that's what the setup looks like, right? That's the round bottom flask. You heat it up, and as it evaporates, it's going to be collected. So here's where we're taking and collecting the water. This is salt water, and then the salt will be left behind. Okay. All right. Let's do an example. If you have ethyl acetate and butyl acetate, you can see the difference there. A mixture containing equal numbers of moles of butyl and ethyl acetate was separated using distillation. Based on the diagram shown above, which of the following identifies a substance that would be initially present in higher concentration in the distillate? So, here, let me give you the choices. So, an equal mixture is of ethyl acetate and butyl. Butyl is the one that's larger, right? So, if it's a bigger molecule, would it boil first or last? Last, right? Because if it's a bigger molecule, what do we know about its intermolecular forces? More, London just because it's more polarizable. Larger the molecule, more polarizable it is. So based on that, A, B, C, or D? You're never breaking CC bonds in boiling. No. This is a covalent bond. In order to break this, That's a chemical reaction. That's not happening. It's speed. Right? Ethyl acetate has the weaker London dispersion forces because it's the shorter carbon chain, and that's the one that's going to be higher concentration in the distillate because it's going to boil first. Yes. Yes. Yeah. Where's the concentration? Oh, higher concentration, yes, because initially it's equal molarity. How can it be equal molarity after you boil it? The whole point is you're getting one to boil first and then the second one to boil last. You got to boil one of them first. It's ethyl acetate. Yeah, which of the following identifies a substance that would be initially present in higher concentration in the distillate, and why? Because ethyl acetate has the shorter carbon chain. Mm-hmm. That is boiling out. Mm-hmm. Well, when you're doing distillation, you're turning it back into liquid. You're not keeping it. Of course, you're condensing it. You're boiling it, turning it into vapor, cooling it down, and condensing it. That's distillation, right? How else are you going to separate it? Distillation is separation based on differences in boiling point. If you're not boiling it, how are you separating it? Oh, yeah. I don't think they distilled it. No, you must react it with something else to react the rest of the rock ice. And aluminum wouldn't react with whatever they're reacting. That would be my assumption on that. All right, let's talk about this. Butanol and pentanol, anytime it's an alcohol, which means it has what group? OH, right? All right. Student observes that the mixture of butanol and pentanol are miscible. What does it mean for two things to be miscible? What's miscible? What's miscible? You guys don't know miscible? They're mixed together. Miscible means they can be mixed together. Immiscible is they can't be mixed together. Like oil and water are immiscible, but water and lemon juice are miscible. All right, using information in the table above, what technique could the student use to separate the two components of the mixture? Justify your answer. So I want you to tell me, what of the things that we talked about? We talked about chromatography, distillation, filtration. Of those that we talked about, is there one that you can use here to separate the butanol from the pentanol? If so, what's your reasoning behind why you can use that method? So what method are you using? Okay, does everyone agree with that? No? Alex doesn't want to. All right, the difference in boiling point between the two liquids permit their separation by process distillation. In the vapor above a heated mixture, the compound with a lower boiling point, in this case, butanol will predominate, and then when that vapor cools, it passes through the condenser, and then the liquid butanol would be collected. Yeah? Mm-hmm. No. Chromatography has to separate based on differences in polarity. I mean, yeah, this would be really hard to do with chromatography. Distillation. Alec, we've been talking about it for 10 minutes straight now. Exactly. In that flask with the glass tube I'll show you guys what that looks like in a minute. Yes. Give me 2 minutes and I'm going to give you guys a break. Yeah, yeah. Uh-huh. Depends on what the question is asking. In this case, because you want justification, right? You do want to talk about what happens because it says justify your answer. So you have to walk it through. When you boil it, would turn into gas first, and it can be collected, cooled down, and turned into liquid, which would separate it from the rest of the mixture. I mean, you're really saying the same thing a few times over, but that's really what you're saying. No, you have to talk about distillation. You have to talk about it would boil first because it has the lower boiling point. Therefore, it can be collected first, and then the rest of the pentanol. The rest of the mixture would be just pentanol. Okay? So, again, distillation is separation based on boiling point, and the difference in boiling point has to do with difference in intermolecular interaction. Yeah? All right. We're going to